Okay, so let's start. This time I will talk about twig.js, the templating engine for the client side. A few words before, like if it's going too fast or if you have a question, then please raise your hand or something, and so that we can directly address it. So why should you use, basically the agenda, why should you use twig.js and why not something else that already exists? How does twig.js work? Then we will go to aesthetic and asset variables that you can use. And last but not least, we will take a look at a few use cases where you can use twig.js and where it excels at and what you should not use twig.js for. So why twig.js? Basically, I did a quick search on JavaScript templating engines, and there's really many of them coming up. Underscore, John Risig's micro templating, Mustache, JS, Beard, JS Render, Smarty Inspired, JSmart. So there is basically many templating engines out there for JavaScript, so why create another one and not use one of these? Well, basically, it depends what you use or what do you want to use the templating engine for. So what does it offer? Well, basically, it offers all the same things that Twig itself offers, like it's fast, it's secure, it's flexible, concise, extensible. It basically has the same syntax like Twig. So if you write your templates, they look the same like Twig, and there's really no difference there. Also, one very important thing, it allows you to use the same template for the server side and for the client side. This is really the most important thing. And what it does not, it's not a pure JavaScript implementation. So it always requires PHP to compile. And it doesn't really have a parser and a lexer and a compiler in JavaScript. So it requires PHP. How does it do that? Basically, it uses Twig, the lexer from Twig and the parser from Twig, and just runs that through. So basically, we start with a template, what you see at the top. That's a normal Twig template. The only thing that's different here is that we use the twig.js tag, and that's basically telling the compiler internally how it should name the function for the template. Basically, in JavaScript, everything is a function, so that's the name of the function that we get at the end. What it does, so it uses Twig to parse that code and to transform it into what you see as an AST. Basically, it's a lot of nodes, like starting with a module node, and then we have, in that case, for example, a string node and a filter that is being applied to a variable. And that's all done by Twig itself. This is not twig.js at this point. So where twig.js comes in then, basically, is it's sitting on top of that AST. After that AST has been built by Twig, twig.js basically uses that AST to compile it to JavaScript code. And that looks like what you see in third position there. Basically, it's a function which gets passed an environment, like a Twig environment, but for in JavaScript, and it's inheriting from a base template. Basically, what the inherits method is doing here, it's copying over the prototype of the base template into the hello world function. And then we have a render method, which basically just the same like echo in PHP. It just builds up the HTML code that we want to produce later. So the important difference is twig.js is not pure JavaScript based. It has a PHP compilation step built in, and therefore if you want to use it with Node, then you also need to have PHP on your server. So for Node, if you want to use it with Node, it's probably not such a good idea, and you should probably better use a pure JavaScript based implementation. But if you want to use it in a Symfony 2 context, that's perfectly legitimate to require that you have PHP on the server. So how does Twig work internally? Basically, we have two distinct things we have the compilation time, which is done in PHP, and then we have the runtime, which is entirely JavaScript based. And functions, filters, and tests, all that you know from Twig, belongs to the compilation side as well as to the runtime side. I think I also have an example in code here. So, for example, if we have this Twig template, it's pretty simple. It doesn't do anything useful. But we are setting a foo variable basically with a string, and then we are applying the trim filter to it. So how does it look if we use a runtime filter? Basically, start with the index HTML. So if you're using a runtime filter, what we are doing basically, we're including twig.js runtime environment. This is the first line, this one. Then we are including the compiled PHP, the compiled JavaScript file by PHP, which is the second file. And third, we are adding basically what the Twig symbol is referring to here is an instance of the Twig environment. And we're telling the Twig environment that we want to add in filter, the trim filter in this case, and we are basically referencing this with the jQuery trim function. So if someone calls a trim filter in your Twig template, then we would basically delegate that call to the jQuery trim filter. And then, of course, the render call, which would actually produce the HTML and render the foo template. Now, how does it look if we use a runtime filter? Basically, this would be the compiled template, and it's also like a class structure. It's inheriting from the base template, and we're calling the constructor of the base template in this line, passing the environment. But the important difference is this line here. You're basically at runtime delegating to the environment to look up which filter function basically trim refers to. So this is a runtime operation, and it's not done at PHP compile time. We also have the option to register a compile time filter. In which case we basically can skip the runtime registration, and we also have the render call, of course, because we're rendering the template, but we do not need to tell Twig anymore that there is a trim filter, but we already have compiled that in at this point. So instead of the environment call, like twig env filter, trim, and so on, we instead have directly the function which we want to call, like the jQuery trim function. So this would be in that case a compile time filter. And we get to that a bit more later, so that's getting a bit more clear. Okay. So on the PHP side, we basically have this one class. This is the JS compiler, which has many subcompilers. Like we have different compilers for the types, which are basically telling what should we do with the node class. Like if you have a module node, how should I rewrite that module node into a JavaScript code? Like if you remember the AST code that I showed you, like with the module node and the string nodes and so on, all of that needs to be somehow rewritten to PHP, to JavaScript code. And that's basically what all of these different compilers are doing. And you can actually write your own compilers, which are compiling your own nodes if you need to. So we have like type compilers. I'm going to give some examples here because this is not so simple. Like, for example, a simple type compiler is the text compiler. This is basically if you have any text in your template like hello or something, which is not a variable or something else, just a string, then this compiler is being called for this. And what it gets is basically the instance of the node, which is in this case no text. And what it does here is simply appending the text to the HTML code that we already have. Important difference here is in PHP we use echo all the time. In the JavaScript version we have something, the SB here is referring to a string buffer, which is basically containing the HTML code. You might ask yourself, why are we using a function here, a function call, and not a plus equals sign, for example? Like you could write something like write SB plus equal instead. The difference is here that this line here is fast in Firefox code and in Chrome, but for Internet Explorer it's pretty slow. And Internet Explorer, we're internally basically building up an array. So what this call here, instead of this call, we are using this call, and it's basically either building up an array or internally doing like plus equal for Firefox, or it's doing actually push, and SB is an array in that case, pushing the content on there for Internet Explorer. To preserve the speed. So that's why we're adding an additional method call. That's a type compiler. We also have like other compilers like function compilers and filter compilers. I don't want to show many of them because it's mostly always the same thing. Basically, we are rewriting the AST node into JavaScript code. In this case, it's the divisible by filter. And we were simply, it looks pretty similar to PHP actually, in that case. So if you have a filter, you can either do it at runtime, like register it, or you can do it at compile time, in which case you need to write some PHP code to transform it into the JavaScript code that you like. Then we also have what I call the function map and the filter map. These are a bit different from the compilers because it's basically just a map. How do we translate the string name like trim into a JavaScript function name? So this is really just a map of strings to strings, and it's basically looking that up in the map and then basically writing that function in the code, like you have seen before, where we had this. This is actually just a lookup in a map, like internally an array, and this array has a trim key, and that trim key is pointing to a jQuery trim string. So it's basically just a string replacement that it's doing, but it's done at compile time, so it doesn't need to be looked up at runtime, and it's thus faster. The same also is possible for functions, of course. So on the JavaScript side, we also have a pretty similar architecture, like the environment, which is holding everything together with the functions and filters and also extensions and globals. And all of that is basically mirrored to how Twig works internally. Just an example here, how you can write your own extension, runtime customization. Basically, we're again including the twig.js runtime environment. Then we're including an extensions file where we have stored our extension, and we basically add it to the Twig environment. So this really looks very similar to how your PHP code looks like. And the extension, of course, is also extending a base class like in PHP, and then you can selectively choose, hey, I want to add functions, so I override the functions method, and in that case we would basically have an extension where we add a Twig function, trim function to the Twig environment. So you could use a trim function in your code if you registered this extension. The same, of course, works for tests and globals and functions. Now I want to get to the static variables, because that's the part where a pretty tough problem is being solved. Basically, if you have your JavaScript and if you have an international language, then how do you make the JavaScript internationalizable? And that is basically solved by static variables, and therefore I want to spend some time on this. So instead of doing all the examples that I've given until now, like included the twig.js runtime environment, then the compiled template, but I haven't really showed how the template is compiled. Like, do I have to run a task every time to compile the template, or how is it done? So in order to understand that, we are heavily, or accomplish that, we're heavily relying on a static to do that for us. And the static integration to Symfony is very good, so that's no problem at all. Basically, what we are doing, we're taking the one twig template that we have, and we are running it through a static, and a static produces different versions of the template. Like, you have an English version, and you have a German version, and you have a French version, or whatever template you want to like. So you have different files. These are actually different files. That's not one file anymore, but you have like a foo.de template and a foo.en template and a foo.fr template, for example. So these are distinct files. How does it do that? Basically, we have this process. We are starting with a static filter. Then a compile request. This is just an overview. I will give an example right now. Then we have a compile request, a handler, which is handling it, and then we are at the JS compiler again, which builds our JavaScript code. So I want to go into the actual code. This was just an overview so that you can follow it. So we are starting at the filter for a static, which is basically what you call in your template if you make an static call. It has basically two methods, the dump method and the load method. And we are basically, what it does is it's creating a compile request with the source path of the template and its content, and it also has defines. We will get to the defines later. And that is then being processed by the compile request handler, which then returns our compiled code, JavaScript code in that case. So how would you use that in your template? Basically, what you have to do is like a normal static call, where you include JavaScripts in your code. So in that case, we are going to include not a JavaScript file, but we are instead including a twig file. And we are running that twig file first through the twig.js filter, which we have just seen. And then we will run it through the Vue.js, for example, just to remove comments and stuff, but that's entirely optional. You can use another JavaScript compiler if you like to. And then we have this line here. Basically, we're telling it which variables the template uses. And in that case, we tell it that we have a variable locale which changes. And so it knows that it needs to produce different assets for each of the locales that are available. Like one asset for the DE locale, one asset for the EN locale, and so on. So it knows actually I need to produce different outputs when I compile that. And the actual usage here is that you can use the same function. Basically, it's the same function name. You do not need to change your code at all. So you still call the hello function. If you wouldn't need to internationalize your function, you could simply leave that out, and the code would still work. Yeah, it would just be like one language in the file, and not different languages. So you can easily upgrade your site. First start with one language and then easily upgrade to multiple languages later on by just adding that you have the variable locale in the template. So after, actually want to give an example so that you know how the compiled code looks like. This, for example, would be if you have it not internationalized. So if we take a look at the Hello World twig template, it could look like this. Like we have a string which we want to translate in a default translation. And we are passing a variable to the trans filter, which should also be replaced. So if we were going to use that without the variables addition to the static tag, then basically we would get code like this here. So it wouldn't replace that trans filter call which we have made, but simply keep it in line and would look if there is some filter at runtime which can actually do the replacement. But this is not really useful because then we would need to like transfer all the translations that exist to the client, and so that we can make the lookup at runtime. So it's not really usable like this. Now, if we add the variable, the vars tag to the static inclusion tag, where is it? Now if we add this line here, then it gets much better because the translation filter actually can look up the translation for us at compile time and can inline that translation into the code. So if we have added this, our compiled code would produce two files, not one anymore. And one file, like the German file, would look like this. Like we have directly inlined the translation that we have on our server. We have inlined it into the JavaScript code. And we have replaced the runtime lookup basically with the compile time lookup. So if you don't have variable replacement, then actually it would just be a string, like if you have just hello, then basically it would even be simpler and would skip the replacement call at all. So this is pretty much better than sending every translation that we have and every translation that might not even be used in the template to the client. We just send like compiled code that already contains all the translations. The English version, the same thing. We have the English text here. If you had a French version or a Spanish version, you would directly have that translation inlined into the code here. Now, how does that work if we have just like one inclusion? Like, how does the static know which asset to include at this point here? The asset URL can only point like to one asset, and we need to make sure that like the German users are getting the German version of our compiled asset and not like the English version with the English translation. So how can a static know how to include the right file here? How it does that is basically it has, if we look at the Twig static extension, then we basically see that it's adding several globals to the Twig scope. So this is, if your server template is called server-side, then these global variables are available. And important is to know that we have something that is called a value supplier here, which basically determines the runtime values for our compile time variables. That's not so easy to understand. So let's take a look at how that looks. Basically, what the value supplier does is it's setting the locale to the locale of the request, and then a static is doing a lookup in its compiled map, and and checking, do I have an asset which is compiled for these variables? And if it has, then it's basically serving that asset. So if a German user is accessing your request, then basically he gets the asset which has been compiled for the German version. If an English user comes to your website, he gets the English version, of course. So that's where the default value supplier comes in. You could also do things like, I want to do like different versions of my assets for like Internet Explorer or Firefox. I want to write out some code like which is fixing some bug on Internet Explorer, but which the other browsers don't need. So you could also use that for things like that, and determining the browser on the server side, and then just delivering the JavaScript which is necessary for this specific browser. So that's another use case which is possible here. Okay, now to some use cases, how you can use it. The first one, what I want to show you, is a client-side application. It's basically, I have an example here, something that I've written lately. It's basically what we see here, a code browser. Basically what it does allow you is you can browse some code on GitHub. And it attaches some information to that code. So if this is entirely JavaScript based. I hope I have a connection, yep. Basically now it has called the GitHub API, and we read or found the bundle. Now it's loading the branches and the content of the repository. And you basically can click through here and you see the code. So that entire thing is JavaScript based. Actually, the only line that is rendered on the server side are these two. The rest is everything done in twig.js and JavaScript. So how do we do that? Basically, what we already have seen, we're including the different templates that we have. Like we have a base HTML template, we have a homepage template, a repository index template, and we are letting all of that compile using twig.js filter and UJS filter, and we are also compiling different assets for different languages. And then we are calling basically at the end, we're calling an init function which basically builds up the entire site. So how can you take advantage of twig.js here? Let's look at one of the functions, like the render functions, which is rendering which files exist in the repository. So this one. And we basically have some template data here. And we're calling a render template function, which is proxying to the twig render call. And we're passing the template name of the repository index and the template data. Then we are doing the lookup. What you have seen, it has loaded the branches at some point, and then the indexes of that file. So we are first rendering like the template for better user experience, so that he doesn't have to wait until all the data is there, because it might take some time depending on how big the repository is and stuff. So we're rendering like the first version of the template with no data at all, just like which repository is being called and so on. And then we are making a call to the API of GitHub and retrieving additional data. So how does the template look like? It's actually a bit more complex. So this template is called multiple times. Like each time we get new data, we call that template and render it out to the user. So one thing here, we have a macro, okay, which is also used. And then we have like what you have seen, like which repository is called, the name of the repository, and we have like the available branches of the repository, which are available after a certain point. So if they are defined, they are not always defined, but if they are, we are going to render out the different options of that template. Then we are rendering out the different paths of the template, the different folders that exist, and if we already have the files, we're also rendering out the files. Or if a content of a file is being viewed, then we're rendering out the content of the file here. So this template is called multiple times depending on which data we already have from the server. So let's take another look at how that works. So basically, the first time we call it, we just have the name of the repository and the different, or the path that is being accessed in the repository. Then we are rendering just the template with that information, and it's displaying like loading additional data. Then we make a call to the API of GitHub. I actually want to show that because that's also really cool. So we are making a call to the get branches function, which is basically proxying to the GitHub API and selecting some data from GitHub. And the important thing is we are not like returning the actual data here, but we are always returning deferred objects, which is pretty cool because it allows us to like sequentially build together the website, and we can display the information as soon as it is available to the user and do not need to wait for all requests to be processed. So we're basically calling here the GitHub API and waiting for the several branches to come back. And then we are basically resolving that, which then calls our then function in the code browser application. So as soon as the branches are available, if they are already in the cache, for example, we wouldn't have any API call at all, but we could like right immediately render that data. I'm not sure if you have noticed it, like if we were going back, it's like there instantly, because the data is already on the server, on the client side, and we just need to render the template. Now, if I move over here, for example, it takes a bit until it loads the data. Now, if we go back and go again there, it already has that and can render like immediately. If the connection were a bit faster, somewhere else, then it should like render immediately as well, because we're already retrieving the data like when we are hovering over that and not waiting until the user actually clicks on the links. So that's pretty cool. If you want to like have a good user experience, you can use client-side rendering, and it's like there instantly. The rest of the data, we are basically nesting that. Like if we have the branches, we're going to select the files, and if we have the files, we can select specific file contents of the file. So all of that is like nested. When the data is available, we can like go to the next step. So that was the first use case. Like if you have a pure client-side implementation, that where you want to have fast rendering processes and then wait for server-side to render the HTML. That's the first use case where you can use it. The second use case is actually if you want to render small pieces on the client side, but which need to be like internationalized, for example. Then what you have seen in the one template, we had a macro, repository index. We had a macro here, which is basically a function in Twig. And we call that macro with different data. In that case, that macro is just like displaying a hover card. If someone moves the mouse over a certain element, then we are displaying the hover card. So how does that look in code? Basically, it's this here. a certain event is triggered, like the mouse is moving over the variable or some diff element, and then we're getting this function call, which is building together the template data, and then we can basically in Twig also call that macro in the template directly by passing the template function and the macro name, and of course the arguments that we want to pass to the macro function. So you can also call macros directly, or you can also have like templates where you just have macros, and then you can just call these macros directly from your JavaScript code. And of course, it's also all eligible for E18N and all the other stuff that you want, and you do not need to concentrate on that. So that's already done for you. A good use case for that is like if you have Bootstrap, for example, if you're using Bootstrap and some of these plugins where you need to generate code for, then you could use macros and basically have them generate the code for you, and you could use the macros on the server side and the client side as well. And the third use case is basically if you have mixed code like client-side rendering and server-side rendering, and you want to use your templates in both. For example, you could say like on the first request, when the page is accessed the first time, for better user experience, I want to render out the data that I have and already display the user like a render page and not have them wait to make an additional JavaScript call just to render or to retrieve the data and then render. So you could like instantly displaying the content. And then if he wants to, like, if you have a calendar, for example, and he wants to click on the next month or something, then you would just need to load the data for the next month and could like then display it on the client side without an additional server-side call. That's the third use case, and this is also a big advantage over the other templating engines that exists, and which simply cannot deliver that because they are pure JavaScript implementations, and you basically have to duplicate the code, like the template code on the server side and on the client side, if you use these, or embed it in the HTML page, for example, which also a lot of engines do. So this is better done with twig.js because simply you have one template and you do not need to write the things 2 times. Okay, yeah, I think that's the end. If you have questions,